No, it's kind of like that though. It must be greater than, it's simpler than that, the third side. So if this is not true, it can't be equal to, or we got flatso. It can be less than, or we've got the T-Rex arms. So that's the idea we're talking about. So if I draw myself a little triangle and I label the sides A, B, and C, and I'm drawing a very generic equilateral triangle. This is representing all triangles. Three things must be true. Side A plus side B has to be greater than side C. And then you can switch them around. It also has to be true that side B plus side C is greater than A. And A plus C has to be greater than B. Did I do all of them? We don't usually have to check all three. In the one instance, it would create like a negative length of a side, which doesn't make sense. Okay, it's a lot easier in math when we stop talking about the definitions and we start doing examples, right? So this questions are saying, determine if the following side lengths could form a triangle, and then it says specifically to prove your answer with an inequality. So do you think it makes sense to add, like to do all three of these equations? So last night, I did not have the notes sheet filled out. I was just kind of exploring this and getting ready to teach. And I did. I added these two together to see if they were greater than that. And these two together, and it wasn't necessary. If I add the two bigger numbers, they're always going to be greater than the smaller one. Okay, that's not the one we're concerned about. The one that we need to double check is if we've got a small, medium, and a large number, the ones we want to check is add the small number plus the medium number and see if that's greater than the large number. So we only have to check one of them. The other two are always going to be true. I don't even care if it doesn't make a triangle. If you add two huge numbers together, they're going to be bigger than the small one. So for this one, we will do 8 plus 17 and check and see if it's greater than 24. So make sure you write this one down because we're only doing a few examples. I know it looks like we're doing a million. We're not. We're doing a few and then we're going to move on. So Devin, what do you get when you solve that? Number one. It's what? True, but what's 8 plus 17? Sorry, maybe I wasn't clear. Yes. Okay, so we have 25 is greater than 24. So let's look back at what we're finding. If the following side lengths could form a triangle, yes. And then prove your answer with an inequality. That is the inequality. You can make a triangle because those two small sides are just long enough to make a triangle.
So you only get to check one?
Yes. The other one, you can check all three, but you're going to notice that if I add big numbers together, they're going to be larger than the small one. Yeah.
So that next one doesn't work then?
And did you do number 2? Yeah, what did you get when you did number 2? 6 is greater than 7. Is that true? No, these would not make a triangle. These are not good measurements to make one. T-Rex arms.
About like you could do 7 plus 3.
Yes. That's why I said 2 of them will be true. If you want to try all 3 equations, you can, but all 3 have to be true for it to make a triangle. So normally 2 of the equations will be true, and then the third one is the iffy one. When you add the small side and the medium side, that's the only one that's going to be iffy. All right, let's do 7. So please set up number 7. Again, they're not always in order like small, medium, large. So be careful. Make sure that you're not just adding any 2 numbers together. The two big numbers are always, if you add them up, will always be bigger than the small one. So that's not the order we want to do it in. Add the small one plus the medium one, and make sure it's greater than the large one. So Ashlyn, what did you get on number 7? 23 is greater than 24. No, it's not. So these three lengths would not make a triangle. They wouldn't touch at the top. Any questions on that section? How you figure out if 3 sides could be a triangle? And again, you are welcome to do all 3 equations if you want, but 2 of them will always be true, true, and it's that third one that may or may not. Okay, let's move on. Because of the constraints of triangles, like we talked about, creating this flat triangle or having T-Rex arms, there's only so many measurements that you could have for the third side if you're given 2. It provides these constraints. So they're giving us 2 sides, and we're going to set up an inequality and decide between what 2 values could the third one be. So again, when I first started doing these, I was setting them up to try to find, like to add them all together and subtract them all. Explain this. So I was doing like let's say this was A, B, and then the one we don't know is C. So I was using all 3 equations, and I quickly found it's not necessary. If I do if I do 14 minus the 22, is that a possible side length of a triangle? Why not? It's negative. So because of that, we only need to try 2 of them. So the first one is we can subtract them. 22 minus 14. And then 22 plus 14. I'll show you a picture of what this would look like in a minute. So you're going to subtract the numbers. And on the right-hand side, you'll add the numbers. This will help us find all the possible values for that third side. So finish number 9. And then I'll show you how I think when you see a picture, sometimes it sinks in a little bit better. So Jordan, what did you get for 22 minus 14? 8. And what did you get for 22 plus 14? 6. So this is kind of the idea. If I've got 14 and 22, let's say it's 36. So if how can I draw this? I don't have enough room. The child is in the way. If I've got 14 and 22 and then 36, it's going to be very obtuse.
Yeah, statement check is here.
Yeah.
Okay, can I grab real quick?
Yeah. So this 36 would be, and I can't even draw, but it's like the biggest angle possible. If it's any bigger, we're flat, okay? And this 8 would give me, again, still 14 and 22, but 8 is the smallest that it can be. I don't know how to draw that. So this is the smallest, 8, and then the biggest, 36. To get it between squishing flat, right, and being open too much. Okay, hopefully that helps. Let's try one more. Let's do, are there any that are weird? No, let's just do 12. So please set up number 12 to find those 2 values that it could be in between. That's fun. Good job on your assembly. That assembly was fun. If you and your neighbor paper look like you're both done with 12. Will you please compare, make sure your equations are both set up properly? Make sure you both got the same inequality to show how big or how small that third side can be. Because this was the last example that I was going to do like that. So don't be shy. Carlos, ask Davis what he got.
What? How do you do that?
Eliza, make sure your partners see what you got.
45 minus 9.
Who else looks like they're being shy? Baxter, did you show Lacey? Okay, Baxter, what did you get? How did you set this up? So what's on the other side? Yes. Lacey, what did you get when you did 45 minus 19? And 64. So there's a lot of lengths. 27, 28, 29, 30, 31, 32, right? All the way up to 63. 64, it can't be. It's got to be less than 64. Okay, these ones on the bottom, they look different. They're the same. If a triangle has lengths of 15 and 27, check all the possible lengths for the third side. So we'll set it up the same. We're going to subtract these values to see what the smallest side could be. And add the values to see how big it could possibly be. And then just choose the ones that fit in that parameter. Brianna, what did you get for the 27 minus 15? 42? Yes. So what numbers are between 12 and 42? Yes. No. It says less than, not less than or equal to. 29 works. 18 works. Does 43 work? 43 is too big, and 12 is equal, so those two don't work. Try not to go too fast. Any questions on that section, how you find that one missing side? It could be between these two things. One will make it a little triangle, one will make it a huge obtuse one. Okay, let's go to the back. I like these ones. Okay, so you read that first sentence that's by ordering angles. So this information, this observation is going to get you ready for your trig functions. So what it's wanting you to do is as you see the three sides, they want you to notice that one is small, one is medium, and one is large. So you label those on your picture. One is small, one is medium, one is large. So the smallest angle is always opposite. So right now we're looking at this 7. Do you see that angle B and angle C are touching side 7? And do you see that angle A is across from it? So when it's across from it, we call them opposite. When it's opposite the side, it's not, these are adjacent. This one is opposite. So the smallest angle is always opposite the shortest side. Similarly, the largest angle is always opposite the longest side. So this is our longest side, the 13, which means across from that, angle B will be the biggest angle. Longest side. I feel like that makes sense. Most people can You're like, oh, that makes sense. So we're gonna order the angles from least to greatest. So across from the 7 is angle A. The medium one is across from angle C. And the large side is across from angle B. You can leave it open, Carter, so you don't have to keep standing here. Yes, Carter's gotten up and down like 12 times in the last 2 minutes. Okay, this one that says ordering sides is the same idea. Allie, will you read the sentence that's on the top of that box, the ordering sides box?
The sides of a triangle can be given ordered by comparing them.
All right, you might notice though, we are missing an angle. So I don't know if it's small, medium, or large because I don't know F. Carlos, how do I find the measure of angle F? Okay. Yes. Yeah, so you might want to remind yourself that all the 3 angles in a triangle are going to equal 180 degrees. So to find the missing one, you can do 180 degrees and then minus the 42 and minus the 103. Instead of subtracting them from each other, you subtract them from 108, 180. So see what you get. 36. I think it's 35. Okay, so let's look over the statement. The shortest side is always opposite the smallest angle. They match up. And what do you think on this one? The longest side is always opposite the biggest angle, largest angle. And then it asks us to do an example. Order the sides from least to greatest. So I can see that this is my smallest angle, 35. So I'm going to go across from that. This will be the shortest side, ED. The medium measure of the angle is the 42. So I go across, excuse me, across from that, and DF would be the middle length side. It's pretty obvious that the 103 is the biggest angle, so I go across from that, and EF is the longest side.
Is it just
Yep, so there's just that relationship. Small sides are across from small angles. Big sides are across from big angles, and then the opposite is also true. The big angles are opposite the big sides. Small angles, they never mention the medium ones, but they're just there hanging out in the middle like the middle child. Very resilient. Okay, let's do a couple examples. So we're just going to do number 2. The biggest thing on the homework is they'll sometimes want least to greatest and sometimes greatest to least. Just read the directions carefully. So Ethan, which is going to be my smallest angle on number 2? So you said this is the smallest side, and he's looking across. So T is the smallest. I'll ask what's the middle length side? Sorry, angle. You said it right. So this is the middle length side. The one across from it is the middle measure angle. And the last one we have left is S. I like to do small, medium, large. Some people, it makes it messy for them, but I like to do that so I don't make a silly mistake if I'm going too fast. Any questions on that one? Can you do another example for anybody? Okay. You guys need lunch, I can tell. Okay, this is the asking for the side length. So let's do number 8. Before I can decide which side lengths are small, medium, and large, I have to find the missing angle. So everyone find the missing angle, write it in there. So write in the missing value and then see if you can do them greatest to least. So it's the opposite of what we did a second ago. Greatest to least. And then give your neighbor a minute to figure it out, but then please compare answers. See if you guys are getting them in order. Can you find that missing angle? What the 3 angles together have to equal? And what's that one? Okay, so can you see that missing one? So where's the smallest? This is asking about the smallest side, medium side, large side. So what's the greatest angle measure? What is the side across from? What's that across from it? Yes, so that's the biggest one, right? D. Comma, right? Where's the middle measure?
Because,
No, you guys.
because this is not.
Yes.
This makes the greatest. So it's not even- If that works.
You think it would be hard to find the missing angle first. You know how to find the missing angle? And you can see which one's small, medium, and large. And not just guess. You might feel like you can tell which one's the longest, but sometimes they make weird pictures on purpose, so you can't. That's why I picked this one, because if it's 44 and 46, their two sides are going to look the same as I'm just looking at them with a measuring tape or something. Haley? Yeah? Oh my gosh. What's wrong with you today? Okay, Haley, which one of these is the greatest? What's the longest side? BE, because it's across from the 90-degree angle. Haley, what's the next biggest one? ED. And we're left with DE. If you called it ED, if you called it DB, there's not a specific order you have to write the letters in, as long as you mention both the vertices. So are these hard to correct? Yes, they can be. So again, on these ones, first find the missing measurement. You kind of have to know that. Then decide small, medium, and large. And double check your answers. So any questions on this type of a thing? If you need me to do another example, let me know. Okay. These are my favorite ones. I love using terms. The homework isn't very long, by the way. If you're starting to panic, it's just not very long. Bergen, will you read the hinge theorem?
First is larger than the included angle of the second triangle. Then the side opposite the angle of the first triangle is larger than the side opposite the angle of the second triangle.
Right? That's a lot of words for that. Okay, the if. It's very important. So it says if there's two equal sides on two different triangles. So I'm liking to think it about, like, say these are two sides. Where's my So I got this side, and it's equal to this side, and they're in two different triangles. The next sentence says, if the included angle, so the one that it creates, is larger, so watch, I'm going to make it larger, what's going to happen to that third side as compared to a smaller included angle? Small third side, large third side. That's all it's saying. So kind of fun. So what it's saying is if angle A is greater than angle D, that's what the theorem is saying, then BC will be greater than EF. A hinge, so it creates a hinge. Bigger angle, bigger third side. Smaller angle, smaller third side. There is a converse of the hinge theorem. Ian, will you read that to us?
If two sides of a triangle are congruent to two sides of another triangle, then the side opposite the included angle of the first is larger than the side opposite the included angle of the second triangle. And the included angle of the first triangle is greater than the included angle of the second triangle.
So this is just going backwards. Thank you, Ian. This is just going backwards from what I just said. So still, this has to be the same length as this one. That has not changed. But this one's starting out and saying, if the third side is bigger, then the angle is bigger. If the third side is smaller, then the angle is smaller. So it's starting with the side and concluding the angle. So this one just switches these around. If BC is greater than EF, then angle A is greater than angle D. It just depends on which order they give you the information in. We're going to do one example of each, and then I'll give you the rest of the time, which is slowly being eaten away. Okay, so the first thing I'm looking for is what's the pencil, what's the marker? Right, so here's the pencil, here's the marker. We can use the hinge theorem now, because we've got two sides that are the same. So I'm looking at the 79 and the 74. Which one's bigger? The 79. So if the angle is bigger, the opposite side is bigger. So my little monster is going to eat the big one. So look at number 3. This is 79 and this is 74. So if I'm comparing two angles, this is larger. Smaller. It's a smaller one. Because of the 74 is smaller than the 79. Yeah. Okay. So again, we need a pencil and we need a marker. We need two sides that are equal. Pencil, marker. What is the included angle? Because we have a lot of information here, right? What are you saying, Damon?
You just find the angle right there.
Yes, so this included angle, I need to be comparing it to this one. I don't know this one, but I can find it. They gave me just enough information here, so just keep in mind 180 degrees is always the angles in a triangle. So you can subtract the 93, you can subtract the 32. Damon says it's 55, so which side will be longer? XY or WX? XY, because it's opposite the bigger angle. XY. I can't tell if we're getting this or not. We are kind of going fast. Okay, these are just the opposite idea. You're talking about the angles. So let's look at a hard picture. Let's look at this picture here. Okay, so we have pencil, we have marker. So the included angle is here and here. And we're trying to decide which one's bigger. So again, I'm thinking about hinges. How do I know which one is bigger? Do you see it, Jesus? How do I decide if this angle, the top angle, is bigger than the bottom angle?
You can see that it's 27 and 28.
Yes. This one's opposite 27. This one's opposite 28. 28 would be bigger. So KML will be the bigger one. Okay, I think the best way to see if this is sinking in is to let you work on your own. Please, on this worksheet, do the odds. Baxter, do I have to do all of them? The odds. Ethan, do I have to do all of them? Which ones do I have to do? Does anybody else? Mine was 3 times enough. This follows your notes exactly. So if you've already forgotten how to decide if 3 sides could be a triangle, put your notes on that first page. It'll remind you how to do it.